Hello and welcome to the video. In this one, we are going to build a simple but functioning backend using the code we generated in the previous video. The project is almost exactly as we left it in the last video. We have our dependencies in package.json, they are installed, and our generated code is in src/generated based on the bookstore OpenAPI document. If this doesn't sound familiar, I'd recommend checking out the video series from the beginning. Since the last video, I have made this folder a Git repository, and I committed everything, so it's easier to see what is changing. We want to start writing code, and we want the TypeScript content assist to work properly, so I'm going to start by creating a tsconfig.json file in the project root. Let's open this file and add an object as the root. Let's configure include first. I'm going to add a single path, our source folder, /src. Let's configure exclude next. I'm just going to add node modules. Lastly, let's set up compiler options. I'm setting module to CommonJS, target to ES 2022. I'm turning on strict mode, and I'm also enabling ES module interop. And lastly, I'm configuring lib with a single entry, which is going to be ES 2022. Let's start this by setting up an Express server, just as we would normally. First, let's create a file called create_bookstore_server.ts. This file will contain a single exported function with the same name as the file. Now let's implement this function. First, I'm importing Express. Then I'm creating a constant called server in the function's body, and its value is going to be an Express instance. And then I'm simply returning server. Now let's create another file called index.ts. In this file, I'm simply going to call create_bookstore_server, which returns a new Express server instance. And I'm chaining a listen function call on it with port 5000. Now let's add the script in our package.json so we can conveniently run and rerun the server. So I'm creating an entry called start under scripts, and it's going to run tsnode.src/index.ts. Let's check if this works by using npm start, and it's looking good so far. And now let's check it out using an API Explorer tool. I'm going to use Insomnia in this video, link to it is in the description, but you can use Postman or whatever you are used to. I'm going to quickly import our source OpenAPI document to Insomnia. I'm doing this by going back to VS Code, then to generate.ts. I'm finding and copying the URL of our OpenAPI document, then back to Insomnia. On the dashboard, I'm clicking Create. I'm selecting URL from the drop-down list. I'm pasting the URL, and I hit Fetch and Import. When asked, I'm choosing Request Collection, as we just want to test the requests. A new entry has appeared with our bookstore request collection, so let's click that. Then I'm going to open API env in the top left corner, manage environment. I set host to localhost 5000. Then I'm just clicking done. Now let's check out one of the requests, let's say /books. Clicking on base URL now gives us confirmation that the host value is properly being pulled from Insomnia's environment variables, and our base URL is what we expect. Let's try to run this request. And as expected, we get a 404 as our server lacks any functionality, and we are seeing the default Express behavior for this case. So let's add that missing functionality. First, we create an implementation of our generated bookstore API type. I'm creating a file in the source folder called bookstore_API-imp.ts. Then I'm creating a class with the same name, which implements Bookstore API. I'm using a class implementation for convenience, but you could implement this function by function too, if you don't care about sharing context. Now we can use VS Code's quick fix functionality to automatically create a stub for each method and to add all the imports we need. Let's go back to create_bookstore_server.ts and add a new server.use statement. We are going to use the result of our create_bookstore_router function call. This is a generated function, by the way. And this function needs some parameters that now we can supply. First, I'm passing in an instance of the API implementation we just created, so a new bookstore API imp. Then I'm also passing in an Express server adapter instance, which comes from a supporting oats package. This will be responsible to bridge the generated code with Express, and this default implementation fits our needs perfectly. Since we are expecting JSON in the request body, let's also add the body parser with another server that use call just before our main router. I could use the body parser that ships with Express, but it has some undesirable behavior that is impossible to configure, so I'll use the JSON body parser that ships with oats instead. This is based on Express's text body parser, and the only difference is that it doesn't replace request bodies with an empty object, therefore allows error reporting to be more accurate. Let's restart our server and go back to Insomnia. And now if we hit the same endpoint, we can see that our API implementation was actually called, but since it just throws an error, we get the default Express error handler behavior, which gives us the stack trace. Now our backend is properly set up. The only thing left to do is implement the business logic. The first thing I'm going to do is change all the functions in Bookstore API imp to be async, as it allows us to use nicer syntax. We are going to work on this incrementally, so let's start by adding our data source. To keep it simple, I'm going to use an array that's going to live in memory. It's going to be a private field called books of type book array. You could obviously use any kind of data source in a real app, like a database or another HTTP service, but for our purpose, an array will be okay. To have some data out of the box, I'm going to add one hard-coded book instance. ID is going to be 1, author is going to be me, Balázs, price is going to be 10, and title is going to be test book. As you can see, this is all strictly typed. If I try to, let's say, mistype price by changing it to a string, I get an error. Let's add a simple implementation for our getBooks handler next by simply wrapping the books we have in the appropriate response type. So I'm just going to return an object. I'm setting status code to 200, then MIME type to the only option, which is application/JSON. Body is going to be this.books, and the single extra response header, xLength, is going to be this.books.length. As you can see, each part of the response is strictly typed. If I were to change the status code to, let's say, 400, I'd get an error because the body would be expected to be of array type with app error items. Now let's try what we just did. I'm restarting the server first, then I'm going back to Insomnia, and I hit the same /books endpoint. And as you can see, we got the array with the hard-coded book, we got the proper 200 status code, and if we switch to the header stub, we can see the correct content type header, and xLength as well with the expected value. Okay, so let's implement add book next, so we can create more books on demand. For this, we are going to have to use the request body, as that's where we expect the new book instance to be specified by the client. Now if we check our request type, we can see that we got a generic try type here that wraps our book type. What is this try? Since we have no control over what clients are going to do, we have to prepare for everything. We need to prepare for no request body with the wrong structure, or stuff that's not even serialized to the format we expect. Based on the OpenAPI document we generated from, Oats parses and validates all data before it gets passed to our business logic. But if an Oats library or generated piece of code were to throw an error, we would have no way of handling this in a type-safe way, as TypeScript doesn't do typed catches nor typed rejections for promises. In general, the language gives us no option to declare what we are throwing or what we are expecting to catch for neither synchronous code nor promises. I can't change this as this is a conscious decision by the authors, but I can give you a reasonable alternative. And this is where the try type is going to help us. An oats try can either be a success with a generic data field, or a failure with an array of issues that cause the failure. An issue is a type described by its severity, by a path that will point to the location of the cause, for example a JSON path in case of schema validation, and a message telling us what the problem was. This gives us a more type-safe and practical way to deal with errors. Let's see this in practice. To decide if this request body was parsed and validated successfully or not, we need to determine if request.body is a success or a failure. For this, we will use an if statement, and we can use the isSuccess typeguard function exposed by the try package to check if it's a success. In case of a success, first thing we need is a valid ID for the new book. Since we are doing this without a proper database, let's just find the current largest ID first, then increment it by 1. I'm going to do this by first creating a constant called newID, and its value is going to be this.books, mapped to the ID of the books. Then we find the maximum by spreading this into mat.max. Then we increment it by 1. Then let's create a constant called newBook. Let's not forget to type it as a book. Then make its value an object literal. Spread request.body.data into it first, and then let's specify ID as new ID. Now we can push new book to our books array. Finally, we can return a success response, where status code is going to be 201. MIME type, the only available option, which is application/JSON, and body is new book. Now that the happy path is done, we also need a way to describe the error somehow if the body was incorrect. A basic approach could be to return a response with a generic error message, so let's try that first. After our if statement, I'm going to return an error response, where status code is 400, as the error is definitely caused by bad client data. MIME type is application/JSON, and the body is going to be an array with one app error, having a generic message saying bad input data. Let's restart the server, and jump back to Insomnia, and check the /books endpoint with post. As you can see, Insomnia filled out the request body with some auto-generated data based on our OpenAPI document, which is structurally valid, so let's try to run this request. As expected, we get back our 201 with our book, but with the ID properly incremented to 2. Now let's make the request body invalid by removing the title field, for example, then run it again. As you can see, we get back an error response with the proper status code and our bad input data message. But simply saying our data is invalid does not help at all in figuring out why. If I'm the consumer of this API and I don't have access to the OpenAPI document describing it, and I also have no other resources to debug the problem, I'm completely clueless how the request body should look like. So let's fix that. Let's go back to add book first. After the if statement, since our request body was not a success, it must be of failure type. And the failure type has an array of issues. Since we are returning an array of app error type, the most convenient solution is to map these issues to app errors. So instead of the hard-coded app error, let's map over request.body.issues. The transform function is going to return an app error, so I let the compiler know. And let's return an object with the required message field that's going to be the stringified value of our issue. Let's restart the server and give this another try. To demonstrate the effectiveness of good error messages, I'm just going to delete the request body and see if we can figure out, based on the error messages, what the body should be. If I run the request, we get back a 400 status code as expected, but with a more descriptive message this time. Based on the message, the request body should be an object, so let's make it an object and try again. Now we can see a message about each mandatory field that this object should have, so let's start adding those. I'm adding author and setting its value to foo, and then I'm adding price, making it bar. If I run this request again, we can see that author is fine now, but we still get messages about the rest of the missing fields, and about price, since I mistyped it, as it should be a number. Okay, now I'm going to correct everything based on the messages. I'm setting price to 10 and make it a number this time. Then title and make it sample. It doesn't really matter. And finally ID, which we don't really care about as we auto-generate it anyways, so I'm setting it to 0. In a real app, you should probably create a separate schema in your OpenAPI document for your request bodies, omitting the stuff that the client doesn't need to send. So in our case, a book request schema with the ID field omitted. In this example, I wanted our source OpenAPI document to be as small as possible. That's why I use a unified book type for both requests and responses. And now that everything is fixed, the validation of the request body succeeds, so we can actually create a book instance. I'm going to send the request a few more times. Now that we created a few books, let's run our /books request with get. And so far so good. We have the books array that has all the items we created in it. Let's say in our app we can have quite a few book instances, so let's implement simple paginating. Let's go back to the getBooks function and let's have a look at our request type, getBooksServerRequest. I didn't show this in the previous video, but here we have two parameters spread out between headers and query string. The only reason for not having both of them in the same parameter location is just to showcase both in this video. Both are individual tries, as they can be independently correct or incorrect. The offset query parameter gives us the index of the first book we want, and the xlimit header parameter gives us the amount of items we want to take from that offset. The idea is to make pagination similar to SQL's offset and limit clauses. We would like to only process the request if both parameters could be properly parsed or not present at all, since both of these parameters are optional. We could use the previous approach, but it can get quite tedious to check both tries separately. Fortunately, there is a utility method for this in the try package. To simplify things, I'm going to create a local constant called queryEndHeaders, and its value is going to be the result of the zip function call with both request.query and request.headers. Zip is a utility method from the try package, and its result will either give us a success with a strictly typed tuple as its data, with the data of both of our tries, or a failure with the issues from either or both tries. Now I can use an if statement just as before to check if this combined try is a success. In the body of the if, let's destructure the data of our combined try to queryEndHeaders. We only want to return a section of this array. To be more precise, from the offset index we want to take maximum limit amount of items. To achieve this, we can use the slice method of our books array. This method works slightly differently, as it takes a start and end index. So I'm going to assign the start value first. We are going to take query.offset if present, or fall back to 0. For end, we need to count from the start index and take the amount specified in xlimit, or take the rest of the array to the end if it's not present. We are going to use xoffset from headers, or if not present, this.books.length minus start, parenthesize this, and increment this by start. Now let's create a constant called paginatedBooks, and assign to it the sliced books array using start and end. Now we have the data we want. Let's modify our return response. So body is paginatedBooks, and we modify xLength to the length of paginatedBooks. The last thing we need to do is handle the case when either our query or header parameters were invalid. To achieve this, I'm going to use the same approach as before, mapping our issues in a failure to app errors. I don't want to introduce repetition, so I'm going to encapsulate this into a function. I'm going back to the addBook handler. I'm finding the body field of our 400 response, and I'm selecting its value up until the trailing comma. Now I'm clicking the little light bulb here, which is VS Code's code action menu, and I'm selecting extract2 method in class. When prompted, I'm going to call this function failure to app errors. Something isn't right here. We are taking an addBook specific request object as parameter, so let's change that. Let's call this parameter failure and make it of type failure as well. And now I'm just going to replace request.body with the failure parameter. So it's not mixed in with the rest of the request handlers. I'm moving this function above the first request handler. Let's go back to the addBook handler, where now we have a compiler error, and quickly fix that by changing request to request.body, which is a failure at this point. Now we can go back to getBooks and construct the error response. MIME type is going to be application/JSON, status code is going to be 400, and the body is going to be the result of a failure to app errors call with queryEndHeaders as its parameter, for which we know at this point that it's a failure. Let's restart the server so we can test the new behavior. Since we restarted the server, we have lost all the data we previously created. So let's execute the post request and create 4 books, so we have 5 in total with the hard-coded one. Now let's hit /books with get without any parameters, and we expect to get all 5 of the books. And that's indeed what we get. Now let's go to the query tab, enable the offset parameter, and set its value to 1. What we expect to happen is the first hard-coded book to be skipped. And as you can see, that's exactly what's happening. Now let's go over to the header tab, where we can configure request headers, enable xlimit, and set its value to 3. What we expect is 3 items from the second item. You can track this by looking at the IDs. And that's exactly what we get. Okay, so we tested that our business logic is working fine, but what if we send these parameters with the wrong format? I'm going back to the query tab and setting offset to ABC, which is of the wrong type, so the request should fail with 400 and with a proper explanation of the issue. And this is exactly what we see here. What if I mess up the header as well by changing it to, let's say, false? And now we have an error for both. And with that, we have our second functioning endpoint that fully respects the source OpenAPI document. So now only one handler remains, getBook, which just returns a book by its ID. The ID is being sent as a path parameter. In this case, we also need to prepare for semantically invalid input, meaning if we don't have a book with the matching ID, we need to handle it. First things first, let's start with the usual parameter correctness check with an if statement that checks if request.path is a success. If so, let's destructure its data and assign the only path parameter book ID to a constant. Now let's find the appropriate book. I'm creating a constant called book, and I'm using the find method on this.books. In the predicate, I'm simply comparing the iterated book's ID with book ID. If we hover over a book now, we can see that it's either a book or undefined. Undefined meaning we didn't find the book. So let's add the nested if and check if book is undefined. If it is, let's return a response explaining this. MIME type is going to be application/JSON as usual. Status code is going to be 400. And the body is going to be an array with a single app error saying book with ID book ID doesn't exist. After this nested if, we can return the proper 200 response, as we know the requested book has been found. MIME type is application/JSON here as well. Status code is 200, and the body is simply the book we found. And after the main if, we need to return another type of error if there was an issue parsing the book ID path parameter. The MIME type is JSON as usual. Status code is 400. And the body is going to be the result of a failure to app errors call with request.path. Let's restart the server, then go back to Insomnia. After each restart, we only have a single book that we have hard-coded in the books list. Let's validate this by requesting /books with get. And here our only book's ID is 1. So let's click on the /books/book ID request, change the parameter placeholder to 1 and run it. As you can see, we get the single book instance as expected. Now let's try to send a string, let's say ABC, instead of a number for book ID. And as expected, we detected this and got back the appropriate error. Now let's check out what happens if the ID parameter is structurally valid, so it's a number, but semantically invalid, meaning it's an ID of a book that doesn't exist. Let's say 10. And here is our custom app error. Our API implementation in theory fully respects the source OpenAPI document. But what if something unexpected happens and our business logic throws an error? Let's go back to getBooks, comment out the body of this function, and add the throw new error statement instead with a frowny face as the message. Let's restart the server as usual. Now let's open Insomnia and check what's happening. Once I make the request to /books with get, we get back a 500 status code and the stack trace as HTML. In this case, we are violating our own OpenAPI contract, as we promised app errors with JSON MIME type along with the 500 status code, but that's not what we see here. For this, I can't provide an out-of-the-box solution, as I can't know in advance what error handling and reporting strategy you will be using. But I can show you a simple and generic way to deal with unexpected errors in handlers. Let's go back to the generated getBooks router first. If you remember, in our generated router code, all the logic, including the call to the methods of our API implementation, is in a try-catch. And the way errors are handled by default is simply calling the next method in the adopter's error handler. We could create a custom adopter and override this logic, but we could also override Express's default error handling logic, which I think reads cleaner. If you remember, I made the bookstore example in a way, so for each of our endpoints, a 500 status code with an array of app errors is a possibility, so we can handle this in a uniform way. So let's go back to create bookstore server.ts and add the middleware to our server with 4 parameters this time. Our first parameter is going to be error, then the request, the response, and finally next. It's important that you don't omit any of the parameters, as Express only considers a middleware as an error handler if the parameter count is 4. Strictly typing the response with the app error array generic type argument can help here to make our intention clear. So first, let's call this status method on response with 500. Then chain a JSON function call on it with an array parameter that has a single app error that will have a generic message saying internal server error. In my opinion, it's good to provide clear error messages if you can, but in this case we most likely caught an error, which is a bug in our business logic. So it's safer not to expose the full message or stack trace of the caught error to the user. But it's worth logging the error so we can see what's going wrong on the server side at least. So let's add the console.error statement and log the error here. Let's restart the server and check again how this error is handled. When I hit /books, we get back a proper 500 status code and our JSON app error array. And now we have the single generic error message we expect. But if we go back to VS Code, we see the error logged in the terminal. But now before I forget, let's go back to the API implementation, remove that throw statement, and uncomment our business logic. When developing a real backend, obviously your data source and logging will be different, and your semantic validation would be more detailed. But hopefully you got an idea of what oats can do for you on the server side, and how quickly you can prototype APIs with it. I hope I also managed to capture how easily you can provide meaningful error messages to your clients. That concludes this video. If you have any questions, comments, feedback, or anything you'd like to share, please do so in the comments or on the discussion page on GitHub. Links as always in the description. I hope to see you in the next video, where we are going to check out multiple strategies of testing for what we just built. And for some of the testing solutions, we are going to use the generated client-side code. That is the same thing you could use in the browser to consume this API.